Solving a rational inequality, solve and graph the solution set. So we have 2x over x plus 1 greater than 1. So what we do in here, first of all, we are going to subtract minus 1 both sides of inequality. And what we are going to have here is a 2x is divided by x plus 1 and minus 1. And the other side here, minus 1 is going to be 0. And this is a minus 1. And this is a greater than 0. So, but now here I can write 2x, x plus 1, minus 1, I can write like x plus 1 divided by x plus 1. So let me write here 2x, let me write a different color, 2x over x plus 1, and instead of a minus 1 I'm going to write, as I said, x plus 1 divided by x plus 1, because I want to make this denominator the same. So is x plus 1. And now if I am x plus 1 is a greater than 0. And now here, if this minus is going to subtract both the signs here, and what is going to be 2x minus x is just the x is here, and on the other side the minus 1 is here, and the denominator is LCD is the same. So LCD is x plus 1, so denominator is x plus 1, and this is a greater than 0. And now I'm going to take x minus 1 to equate with 0. So I want to find those regions. X minus 1, I'm equating with 0, and I'm solving for x. So it means x is going to be equal with 1. And same thing I'm going to do with the denominator. And I'm taking denominator here, and I'm taking x plus 1. I'm equating with 0, the denominator here, this denominator. I'm equating with 0, and I'm solving for x. When we solve for x, then x is going to be equal with a minus 1. So now those are the points that divides in the region the number line. So what do we have here? We have a minus 1 is here. Let's say here is minus 1. And 1 is here. So we have 3 regions. 1 region here of the interval, second, and 3 intervals. So first of all, here let's take the first interval. Let's say interval 1. And let's check is it true or false. This is a part of the solution. But what we are doing here, I'm taking the minus 2. And I'm plugging here minus 2. Okay? And just let me write here the interval what we are taking. We're taking the interval from minus infinity to minus 1. And I'm taking here a parenthesis because this is an open interval. And this sign here, operator, tells me is the open interval. And if I'm taking minus 2 here, minus 2, minus 1 is a minus 3. Okay, this is a minus 3. And now here, minus 2. Plus 1 is a minus 1. Minus 1 is greater than 0. So this is true because negative 3 divided by negative 1 is a positive 3, and this is true. So this is a part of the solution. But first of all, let me see here in the region 2 from minus 1 to 1. So the region 2 here, or the interval 2 is better to say, I am taking a 0 to test in this inequality. And what I'm doing here, if I'm plugging instead of the x 0, is 0 minus 1, which is a minus 1. So just let me write here the interval. I think is better if I write from minus 1 to 1 in this interval. And as I said, I'm taking a 0. I'm plugging here 0 minus 1 is a minus 1. And now here 0 plus 1 is a plus 1, is a positive 1, is a greater than 0. But this is a false because minus 1 divided by 1 is minus 1, and minus 1 is not greater than 0, but it's less than 0. That's why this is a false. And in this region here is a false. So just let me take a different color and let me write here this region here is the solution. So the solution is in this interval from minus infinity to minus 1 is a solution. But here from minus 1 to 1 is not a solution. But now let me check from 1 to infinity is a solution. So the region 3 is a solution or not. And let me write the region 3 here. Okay. Region 3 here. And I'm looking from 1 to infinity is a solution or not. So now let me take any number here. But I'm taking integer 2 because it's much easier to. Let me write here again from the interval from 1 to positive infinity here. And I can take any number between 1 and infinity to check here does it satisfy this inequality or not. So I'm taking number 2 here and I'm checking. 2 minus 1 is positive 1. Okay, and now here 2 plus 1 is 3. And 1 over 3 is greater than 0. So it's satisfied. It means this is a part of the solution. So, and this part is of the solution. And we can write here. But 1 is not a part of the solution. So endpoint of this open interval is not a part of the, is not a solution of this inequality. Okay, here is the solution. And now we can say is the x. Any x that we take is element of the open interval from minus infinity to minus 1. And union, so in this interval, where we are taking x from 1 to infinity is going to be part of solution of this inequality, or is going to satisfy this inequality here.